Section 9.1, we're working with radicals, and a lot of this you will be already familiar with, and it's pretty easy to catch up on. So first thing is this one. When you multiply two radicals together, all you do is multiply them. Now in order to multiply them together, I'm going to skip a little bit ahead. If there is no number here on the index, it's always a 2, which indicates a square root. So the ones that you're going to mostly see in Algebra 1 will either be a plain 1, which is always square, or you will see a cube root. And the cube root is what number do you see 3 times? So it's what number is multiplied 3 times inside there. We're jumping ahead a little. But in terms of multiplication for this core concept, when you see two radicals that have the same index, so the index there would be 2 because there's nothing there, all you need to do is multiply them together and then simplify as needed. So let's go on to some examples here. All right, let's simplify these quickly. Square root of 24. So what you're looking for is you're always looking for perfect squares. There's a chart over there on the whiteboard, but you're always looking for perfect squares. So inside 24, where is there a perfect square inside 24? 4, right? So it's 4 times 6. Okay, 4 is my perfect square. That's going to come on the outside. It's going to become a 2, because the square root of 4 is 2, times the square root of 6. So this, you cannot do on a calculator. You need to do these by hands because I want the answer in radical form. I don't want it in decimal form. So you have to know your perfect squares. All right, so let's look at this one. 80. Let's look for some perfect squares inside there. Is 8 a perfect square? No. Is 10 a perfect square? Okay, so how else can we break this up with a perfect square? 40 is not a perfect square, but 4 is. 4 and 20. Oh, but inside 20, there's also a perfect square. So that's 4 and 5. So if you're pretty comfortable with your multiplication tables, you could have been able to see that this is really 16 times 5. 16 times 5 is 80. 16 is a perfect square. It's a perfect square of what? 4. So you take out the 4. There's a negative there. And you leave what's inside, which is the 5. Okay, now look here. In terms of variables, again, if you look at the chart that was made, I think that's just numbers. I don't know if there's a variable one. Okay, it's not. All right. In terms of variables, the first perfect square is x squared. The next perfect square is x to the 4th. The next perfect square is x to the 6th. The next perfect square is x to the 8th. Because this is x to the 4th times x to the 4th. This one is x cubed times x cubed. This one is x squared times x squared. And this one is x times x. So what's the next one here? X to the 10th. Do you guys see the pattern? So what's the pattern? When it's even. Not x, when the exponent is even. So what you're doing is you're looking for groups of 2. All right, let's just break this up. I'm going to write the whole thing out so that you guys can see it. This is really 7 times 7. Do you see that pair there? Okay, so this is really x times x times x. Is there a pair that I could take out? Yes. Okay, so what comes out here?
1, 7.
A 7, good. And then 1, 7. And then what comes out here? How many x's are going to come out?
2.
Only one group is going to go out. One group of 7 is going to go out. And what's left inside the radical? Just an x. Okay, let's do this last one. So 75. Where's my perfect square in 75? What times what?
Uh,
75 is
25 times 3.
25 times 3. Okay, n to the 5th. So I'm just going to write this out so it's easier for you to see right now. But soon, with lots of practice, especially tomorrow in IXL, you're going to see that you're going to get used to it. This is just practice. There's 5 n's there. I'm going to pull out groups of 2. So let's circle the groups of 2. There's one group of 2. There's another group of 2. All right, now let's decide who comes outside the radical. Who comes outside?
5.
A 5 comes outside. How many n's? 2 of them, good. And then what's left inside the radical? A 3 and an n. Very good. Second part of 9-1. Now we're going to do division with square roots. Okay. When you see a giant radical over a fraction, you're going to break it up into 2 smaller fractions. And the rule is you always have to simplify the denominator. Radical 4 simplifies to 2, which is perfect. However, we're going to get some problems where there's a radical on the bottom. Let's move to those. Okay, giant radical sign, we're going to break it up into 2 smaller ones. We're going to simplify when possible. Do you see any perfect squares there? Yes, which one? The 9. Are there any perfect squares inside 23? No, so you leave it as is. And then you simplify this. Now, I'm going to tell you, radical 23, so that you know, radical 23 is a decimal. It's in between radical 25 and radical 16, which means it's in between which whole numbers? 4 and 5. And which one is it closer to?
5.
It's closer to 5. If you put it in your calculator, it'll tell you an exact 4 point something. But I want you to know this because this 3 is a whole number. This is a decimal. You cannot simplify them. If it's stuck inside the radical, you cannot simplify a whole number with a decimal. So this is going to be the final answer. Okay, let's go here. So I'm going to give the negative to the numerator, negative 17 over, what's radical 100? 10. Okay, good. Let's look at this one. Radical 36 over radical z squared. This becomes 6 over z. Good. This one, radical 4x squared over radical 64. And honestly, you don't even need to rewrite it. Some of you guys can already see it. So what does this one simplify to? 2x over 8. All right. Let me warn you. Are there whole numbers here that can simplify? Yes. So simplify it. If you leave it as this, it'll be wrong. So this is going to simplify to x over 4. Okay, cube root. All right, we are looking for the cube roots. Look at the chart at the cube roots. Are there any cube roots inside 54? So 54, let's just break it up, is really 2 times, what is that, 27? Okay. Are any of those 2 a cube root? Which is a cube root? 27. 27 is a cube root of 3. That chart up there, memorize it. Know all your basic cubes. So let's write them down here. The cube for 1 is 1. The cube for 2 is 8. The cube for 3 is 27. The cube for 4 is? The cube for 5 is? Okay, those are the basic ones you have to memorize. So the cube root of 27 is 3. So 3 goes on the outside. Radical 2 stays inside. Okay, let's look at this one. Cube root. Are there any cube roots in 16?
8.
Yes, it's 8. Now, I'm going to do this one so that you can see it. I'm going to write it out. So 8 is a cube root. What's it a cube root of? 2. So that goes on the outside. Okay, done. Now I have to look for groups of 3. It's a cube root. So I'm going to circle a group of 3. How many groups of 3 can I take out here for the x? 1. So 1 goes here. That's done. And what's left inside the radical? 2x.
But we keep the 3 there, the 2x, 3 on the outside.
The cube, you have to write the index. If you don't write the index, it's squared.
Oh, 'cause
So I was a little sloppy. That's an index. I'm a little sloppy. Okay, let's do this one. The cube root of a over negative 27. I should have just split them. The cube root of a over the cube root of negative 27. Now, think about it. It's cube. What times what times what makes negative 27? Negative 3. So it's going to be negative 3 on the denominator. Is a cube? No. So you leave that one as is.
in the radical form.
Radical form. Okay, last one. So I'm going to rewrite this. Now I'm not going to write all those C's out, and I'm not going to write all those D's out. But I want you to start thinking about putting them in groups of 3. Okay, looking at the numerator. Is 25 a cube? No, so it stays there. How many groups of C can I take out? Groups of 3. 2 of them. And how many are going to be left inside? So 25 is left. How many C's are going to be left? 1. Good. How many groups for D? 1. Are any going to be left inside? No. Is 64 a perfect cube? Yep, it's a perfect cube of? Now, whole numbers. There's no whole numbers for me to reduce. That's my final answer.